In some word problems, you'll be asked to use formulas. One of the most common formulas is the distance formula, which is D equals R times T. Now, it's important to understand what each variable stands for. The variable D stands for the distance traveled in the word problem. The variable R stands for the rate of speed that the object is traveling. The variable T stands for the amount of time that the object is actually traveling. So it's important to remember that since there's three variables, a word problem can give you any two. I can give you the distance and the rate, and you'll be asked to find the time. It's in the time, and you'll be asked to find the rate. And I can also give you the rate and the time, and you'll be asked to find the distance. So it's important that as you read the word problems, you pull out the important information and plug them in as follows. So for example, if a car is traveling 60 miles per hour for 3 hours, how far did that car travel? So let's pull out the information that we have. The car is traveling 60 miles per hour, so that's a rate of speed, so R equals 60. For 3 hours, so T, that's an amount of time, so T equals 3. They don't say anything about the distance, but they do ask how far did the car travel. So D is what we're actually looking for. So now that we know where all the numbers go, let's plug them in appropriately. So with the distance formula, D equals R times T, the distance is the one we're looking for, so we don't have anything to plug in there. The rate is 60, and the time is 3. So now you need to simplify. 60 times 3 equals, so that means that the car traveled 180 miles. Let's look at some other distance formula problems using a chart. Here, two cars are 200 miles apart and traveling towards each other on the same road. They meet in 2 hours. 4 miles per hour faster than the other car. What is the speed of each car? Now this word problem using the distance formula isn't as straightforward as the other one. So this is a method that I want you to look at. We can create a chart to represent the distance formula. So here, this column will represent the first car. This column will represent the second car. The next thing we're going to do is across the top of the chart, we're going to actually put our distance formula. I'm going to represent it a little bit differently though. I'm just writing it backwards. So instead of writing D equals R times T, I'm writing the R times T here and setting it equal to D. Same formula, just written differently. Now let's start plugging in what we know. The first car is, let's see, they meet 2 hours is the time. So since they're both meeting in 2 hours, they both can have the number 2 in the time column. One car is traveling 4 miles per hour faster than the other. So here you need to decide which car is doing what. So I'll say if the first car is going X amount of miles per hour, then the second car must be going 4 miles per hour faster than that car. So here for rate, we're going to write X plus 4 to represent the 4 miles per hour faster that this car is going than the first car. The next thing you need to do is write the distance as an expression between these two. So for instance, since distance is equal to the rate times the time, distance here is going to be equal to 2x because x times 2 is 2x. And over here, rate times time is going to give us the distance. So here we're going to have 2 times x plus 4. Now that we've written expressions to represent our distances, there's one last thing that we haven't looked at yet, and that's the fact that they are 200 miles apart. Since both cars are a combined distance of 200 miles apart, what we can do is add together the distance covered by the first car and the distance covered by the second car and set it equal to the total miles apart that they are. So we have 2x plus 2 times x plus 4 equals 200. So now we can simplify and solve. Here, to get rid of the parentheses, we need to multiply 2 times x and 2 times 4. So we get 2x plus 2x plus 8 equals 200. Again, we need to combine like terms. We get 4x plus 8 equals 200. In order to keep solving, we need to get x by itself, which means we need to subtract 8 from both sides. I get 4x equals 1. And now we need to get x by itself, so we need to divide by 4. X equals 48. Now this is the part where you have to make sure you go back and actually answer the question. Here it says, what is the speed of each car? So right now we know that x equals 48. Well, let's look at the speeds of both our cars. If this car's rate is being represented by x, that means the first car is traveling 48 miles per hour. And the second car is traveling x plus 4. So it's 48 plus 4, which gives us 52 miles per hour.
Go.
Let's look at one more problem. 2 cars are leaving Orlando and traveling to Atlanta. The first car is traveling at 50 miles per hour and left Orlando at 8 a.m. The second car is traveling at 70 miles per hour and left Orlando at 11 a.m. How long will it take the second car to pass the first car? Again, here we can create our chart to plug in the information we know and help keep everything organized in order to solve the problem. So again, this row is going to represent the first car. This row is going to represent the second car. And at the top, I'm going to write our distance formula. Now let's plug in everything we know about each car. So, the first car for rate is traveling 50 miles per hour. The second car is traveling 70 miles per hour. Notice I'm plugging in the numbers underneath the rate column. T is what we're actually looking for. How long will it take the second car to pass the first car? So, since we're looking for how long it's going to take the second car to pass the first car, let's represent for T for time. The next thing we need to do is represent an expression for time in the first car. Well, if the first car left at 9 o'clock and the second car left at 11, there's a 2-hour difference. That means the first car is actually traveling 2 hours more than the second car. Now, the same way we did before, we want to represent distance as an expression of rate and time. So, rate times time would give me 50 times t plus 2. And in the second row, I'd have 70t. Now, it's important to understand the relationship between these two distances. Since they're traveling the same distance, what we can do is set the expressions equal to each other, which will give us 50 times t plus 2 equals 70t. Now our job is to just solve for t. So in order to get rid of these parentheses, I need to distribute the 50. Here I have 50 plus 100 equals 70t. Now again, in order to get t by itself, I have to have all the variables on one side. So I'm going to subtract 100 from both sides. It's going to cancel on the left. I'll be left with 50t equals 70t minus 100. The next thing I need to do is get the t's on the same side, so I'm going to subtract the entire term of 70t on both sides, and I'll be left with a negative 20t equals a negative 100. In order to get t by itself, I need to divide by negative 20. So here I'm going to get a t equals 5 hours. So it took 5 hours for the second car to pass the first car.